Good evening and welcome, you all. So, today we are going to start a new chapter, that is laser. In this chapter, we are going to understand what is by laser, how does a laser work, their characteristics, their use, which kind of tools we are going to use in this laser, what are the applications, what are the applications in different field, in defense, in science sector, in communication sector. Then we will discuss what is the difference between the ordinary light and laser light. Okay, so basically a laser or a light beam that are powerful enough to travel a miles into the sky, and it is used to cut a metal also. Although they seem like a recent invention, they have been with us for half a century. The first practical laser was built by Maiman in 1960. At that time, laser were an example of cutting edge technology only. Today, we have a laser at our home, at our office, as well as in shopping centers. Whether we realize it or not, all of us use lasers all day long. But how many of us understand what they are and how they work? That is the important point. So, today we are going to cover all these points in this chapter. Okay. So, let us start one by one. First of all, what is meant by laser? Originally, laser was an abbreviation for light amplification by stimulated emission of radiation. Laser means what? Light amplification by stimulated emission of radiation. So, laser is a device that emit a electromagnetic radiations or light throughout a process is called as stimulated emission. Stimulated emission. So, this laser light or beam have some remarkable properties that we are going to discuss one by one. The first important property of this laser is the light is very monochromatic. Is a monochromatic light. Monochromatic means what? The light with a single frequency or a wavelength. Okay. Second important point is that the light is coherent with the waves all exactly in phase with one another. Coherent means what? There are number of light waves are there. All the waves have same phase with another. That's why the light is nothing but a coherent light. Third one is a laser beam divergence, very less divergence, means there is no deviation in their path. It follows a straight line path with a mile of distance. So that beam is extremely intense. Extremely intense. Intensity is more than our ordinary source, more than the ordinary source. So basically, laser produces a beam of light whose waves have the same frequency, means that wave is monochromatic and all the waves in phase with another, that is, all the waves are coherent. So the beam is also well collimated, means there is no divergence, and it travels a very long distance. So these are the basic properties with laser. Each property we have to discuss in detail in coming slides. Okay. So before starting this laser, we can understand by some basics related with the laser. Okay. First of all, the atom. What is meant by atom? Means, as we know, the atom is nothing but a central nucleus and electron are revolving around the nucleus in a circular orbit. So different electron in different orbits having their own energy, means different orbital electrons having different energy levels. Okay. Nucleus is nothing but a positively charged. It consists a number of protons and neutrons. That proton and neutron also made up with the help of another fundamental particles. It means that proton and neutron is not a fundamental particle. It is made up with the help of another fundamental particles. That is, one proton is made up with the help of 3 quarks, 2 up quark and 1 down quark. Quarks are the fundamental particles. Neutron also made up with the help of 2 down quarks and 1 up quark. 2 down quarks and 1 up quark. Okay. By using this concept, we are going to understand what is meant by laser and how it works. So when a electron revolving around the nucleus in a orbit, in a circular orbit, that circular orbit having its own energy level, if some external energy is provided to that electron or to the orbital electron, at that time the inner orbital electron become excited because it absorbs that incident energy. Due to that, it get excited and it moves to the higher orbit, or it moves to a outermost orbit, it moves to a outer orbit. By losing its energy, or vice versa, if that electron, higher orbital electron, absorbs some energy, it emits some energy and it moves to a ground state. So if we apply some energy to that electron, then that electron jumps to a higher orbit. It jumps to a higher orbit by absorbing some external energy, and that external energy may be in the form of photons. Okay. So basic concept is this: when an orbital electron, lower ground state orbital electron or a lower energy level electron absorbs some external energy in the form of photons, at that time that electron get excited and it moves to a higher orbit. moves to a, or it jumps to a higher orbit. Okay. So when that electron moves to a higher orbit, when that electron moves to a higher orbit and it stay there for a very short time, it stay there for a very short time, when it reaches to a higher orbit, it emits its energy in the form of photon, or a higher orbital electron emits its energy in the form of photons because that electron want to stable. That's why that electron emits a light photon and it moves to a, it jumps to a lower orbit to become a stable electron, to become a stable electron. When the electron drops back to its original orbit, it releases a particle, and that particle is called as photon, and we can measure its energy in the form of photons. So that light is made up of photons. So that light is made up of photons. Initially, inner orbital electron absorbs some extra energy, it gets excited and it moves to a higher orbit. It stays there for some time and again come back to a lower orbit by emitting some energy in the form of photons, or that light, or emitting energy in the form of light, and that light is made up of photons. A simple process. So this is the emission of light and this is the okay. Now next concept is that wavelength of light. Wavelength of light. That in this case light moves in waves that are similar to repel in water. It repels in water. So light is an example of electromagnetic radiation. It does not require a medium to pass because light waves or electromagnetic waves are the transverse wave. In transverse wave, the vibration or oscillation of that particle is perpendicular to the direction of propagation. Is perpendicular to the direction of propagation. That's why transverse wave does not require any medium to move from one place to the another place. But in case of longitudinal wave, it requires a medium because it vibrates or it oscillates parallel to the direction of propagation. Okay, that's why light wave required a medium to transfer, to pass from one place to the another place. It does not require a medium. So what is the wavelength of light? Wavelength of light. The distance it is the distance basically the wave travels in one cycle. How much distance is covered by the wave in a one cycle? That distance is called as wavelength of light. It's called as wavelength of light. So we can represent that wavelength by a symbol lambda. Now how to define the frequency? The number of times a cycle repeated in 1 second. How many times that one cycle repeated in 1 second? In a 1 second is nothing but the frequency of light. Is nothing but the frequency of light. We can measure in terms of hertz or second inverse. Now, how we can relate frequency and wavelength? Both are inversely proportional to each other. Both are inversely proportional to each other. If one quantity increases, it means what? The another quantity is decreases. So lambda is equal to C by F. So lambda is equal to C by F. So now the wavelength of light. If we observe the optical range of an electromagnetic wave, in that case the red having more wavelength than the violet, it means what? Red having less frequency as compared to the blue light or violet light, as well as energy of violet color is more as compared to the energy of red light. It means what? Higher the frequency from red to violet or blue light, lower the wavelength, and less the energy. Okay, this is nothing but the wavelength of light. Is there any doubt in this? If you have any doubt related with any point up to this, you can ask me in comment section. Okay, thank you.